This will be part 2 of our story of the vertebrates. We'll use this diagram here to capture the expansion of vertebrates from the ocean to land and into the air over evolutionary time. And as they expand into new environments, they are going to be evolving new adaptations to cope with the new demands of life. The story again begins with the fish, the first vertebrates. Now, fish emerged in the fossil record around 500 million years ago, but for 100 million years, the age of fish, lots of new species of fish evolved in the ancient oceans. Bones, jaws were some of the characteristics of these early fish. So we have the first vertebrates, and many were predatory. But we want to think about the ancient oceans as teeming with fish, lots of different species. Some of those fish began to invade the freshwater habitats, to swim up the rivers and the streams and get into the lakes, etc. Now, to survive in freshwater, it requires new ways of sort of balancing salt and water in the body, and the kidneys evolved for this purpose. In addition, some of these fish found themselves in ponds that might have had low oxygen content. So fish have gills to absorb oxygen from the water, but when there's not much oxygen in the water, the only other place to get it is the air. And lungs evolved in some of these fish so as to gulp air and absorb the oxygen from the air. So at this stage then, we've got some fish that have lungs living in these aquatic environments. And the stage is set then for the evolution of amphibians. All that remains is a mode of transportation on land, and that would be Tiktaalik. So Tiktaalik then represents that transition from fish to the first tetrapods, the amphibians. Tiktaalik is a transitional species. It had it had scales like a fish. It had several characteristics like an amphibian: a flat head, eyes on the top, a neck that could move. And take a look at its fin. It starts to have the one bone, two bone structure found in future tetrapods. Now, it still had sort of a fin-like structure here, but in later tetrapods we're going to see digits. Here again we can see more clearly the bone structure of a lobe-fin fish here. So we've got a bone structure like this. Tiktaalik, we start to see the one bone, two bone pattern, but we still have kind of a fin structure here. But in later tetrapods, the one bone, two bone, and now we're getting digits. So Tiktaalik was able to pull itself up onto the land. However, Tiktaalik and its descendants, the amphibians, were still dependent upon water for reproduction. So the females would go back into the water and lay the eggs in the water. The eggs would dry out on land. They couldn't lay their eggs on the land. They had to lay them in the water. The males would deposit semen, and fertilization happened in the water. So amphibians were restricted in their environments, but some began to expand further inland, and as such they began to evolve new adaptations to survive on land, to break the connection with water. What we see then in the reptiles then are shelled waterproof eggs. So no longer do reptiles need the water for reproduction. Dry scaly skin to conserve water in dry habitats. The amphibians have moist skin, and they have to remain moist. They will dry out if they can't remain moist. And then internal fertilization, a way of delivering the male semen into the female's body. So again, you don't need water for reproduction. So reptiles evolved a set of characteristics, a set of adaptations for life on dry land. Now, some of those early reptiles branched off into the mammals. And if we think about some of the characteristics of mammals, they can inhabit cooler climates than reptiles. So reptiles are cold-blooded, mammals are warm-blooded. This allows them to maintain a body temperature even when they're living in cooler climates. So again, we see the expansion of some reptiles into cooler habitats and the evolution of adaptations to make that life possible. We have hair for insulation, warm-bloodedness, and mammals also evolved new ways of nourishing their young. So a placenta to nourish the fetus, and then milk production to nourish the baby after it's born. Now, some of those reptiles also evolved into dinosaurs. So dinosaurs, of course, many of them went extinct around 65 million years ago, but not all of them did. Some dinosaurs had already evolved feathers and were beginning to evolve wings. And this would be the line that survived the extinction event that led to the modern birds. Now, Archaeopteryx is an example then of that transition from the reptile, or more specifically dinosaurs, to bird. And this is Archaeopteryx, and we'll see it's got a mix of characteristics. So here are a couple fossils of Archaeopteryx. It had teeth like a reptile, specifically a dinosaur, so modern birds don't have teeth. The dinosaurs did. It had a bony tail like a dinosaur, so modern birds just have feathers for tails. Dinosaurs had bones in the tail, but of course it had feathers as well. So we see Archaeopteryx as a clear transitional organism. It had characteristics of both the ancestral group and the group that would later emerge, the birds. Now we'll end with one more amazing transition that occurred in the mammal group. So some of the mammals that had evolved adaptations for life on land and in cool climates and so on, some of them are going to now expand back into the oceans to make a living. And of course that's the story of the whales. Now whales have ancestors that were four-limbed terrestrial mammals. By 45 million years ago, a species called Pakicetus was living on the shorelines. It had sort of webbed feet and a snout here, and it was feeding on lots of things in the ocean. And in about 10 million years' time, its descendant would be fully aquatic. So again, Pakicetus was running around on the land, but it could also kind of swim in the water, and it reproduced on land. But Durodon down here was fully aquatic. It never got out of the ocean. It's an amazing transformation. Several things were happening. The rear limbs were getting smaller. The front limbs were turning into fins. The nostril was moving up the skull. There were extra vertebrae evolved here, so a longer body. So this is an amazing physical transformation, an evolutionary story. And in fact, in modern whales, there are limb bones inside the body. So in some of these whales, you can actually kind of see that they're big enough to kind of see, and they would be, of course, vestigial limb bones. They are clues to the nature of the ancestor of whales. The ancestor of whales were four-legged mammals that lived on land. Now, whale evolution, we can characterize it in this way. Durodon then would have been an ancestor, and its descendants are going to split into two groups of whales. The toothed whales, like the dolphins and the killer whales, and then the baleen whales. The baleen is the structure in the mouth, and these whales will just gulp up stuff. It can be very small food, and then squirt the water out and just retain the food. So we have lots of examples of whales, and it's an amazing expansion from a land animal back into the ocean with the evolution of adaptations to make that life possible. Now in the final lesson then, we'll ask the question, well, what came before the fish? So we said the fish were the first vertebrates. Well, what was the ancestor to the first fish? And we'll take that up in the final lesson.